So in this video, we talk about the transmission section of the standard surface shader. Let's create a new standard surface shader and assign it to the bottle and the glass objects. And open up the network editor. Transmission allows light to scatter through the surface, so you can create refractive and transmissive materials such as glass, water, honey, chocolate, caramel, and so on using the transmission section. Transmission weight controls how much transmissive or refractive you want the shader to be. At 0, you have no refraction and only base color and specular reflections. And as I increase the transmission weight, we start adding more and more refractive or transmissive quality to this surface. At transmission weight of 1, we have a fully refractive surface and the base color and weight will be ignored and becomes grayed out. That is because standard surface follows energy conservation law. To control how sharp or rough the surface is, you would use the specular roughness. Right now it's set to 0.2, so we get this frosty glass. To get it to be even frostier and rougher, you can increase the specular roughness, and to make it sharper and less blurry, decrease the specular roughness. And this will result in sharper refractions as well as sharper specular reflections. Set it to something like 0.02 for now. If for any reason you want to have rougher or sharper refractions compared to the specular reflections, you can increase or decrease this extra roughness parameter in the transmission section. Right now, the specular roughness is set to 0.02, so we get sharp reflections and refractions. If I want my refractions to be, let's say, 20% rougher compared to the reflections, I can set the transmission extra roughness to plus 0.2. And now we have sharp reflections but rough refractions. And the opposite can happen. If I set the extra roughness to 0 and specular roughness to 0.3, now we have rough reflections and refractions, but if I want my refractions to be like 30% sharper compared to the specular reflections, I can set the extra roughness to minus 0.3. But normally you want the extra roughness to be 0, so both the specular reflections and refractions are having the same roughness. It's a handy option to have, so set the extra roughness to 0 for now and specular roughness to 0.02. The next important parameter for transmissive materials is IOR, or index of refraction. In the previous lesson, I talked about IOR and how it both controls Fresnel reflectivity and index of refraction. So IOR here controls how much light rays will bend as they enter a medium. This value is 1 for vacuum, so the light won't bend in vacuum. 1.33 for water. 1.52 for most household glasses, 2.41 for diamond. You can find IOR values for different transmissive materials on the internet, and you can use these presets that Arnold provides as well. As we are dealing with glass, let's use the glass preset for now. Then we have transmission color, which controls the color of the light when it passes through a transmissive shader. Let's use a very unsaturated greenish blue color with the RGB values of 237, 255, and 252. Transmission color filters the refraction according to the distance traveled by the refracted ray. The longer light travels inside a mesh, the more it is affected by the transmission color. Therefore, for example, green glass gets a deeper green as rays travel through thicker parts. Naturally colored glass has different shades of a color based on its thickness. Thinner parts will be tinted lighter and thicker parts will have darker shades of that color. Right now we see a uniform green color throughout our geometries, and that is because the depth value here is set to 0 centimeter. Depth controls the depth into the volume at which the transmission color is realized. Increasing this value makes the volume thinner, which means less absorption and scattering. It is a scale factor so that you can set a transmission color and then tweak the depth to be appropriate for the size of your object and control how the transmission color affects the thick and the thin parts of your objects. So if we set the depth to something like 2 centimeters, now we get different shades of green on our objects. And as we start to increase the depth value to 3, 5, and let's say 10 centimeters, now because the refracted ray needs to travel much farther through the object before becoming this green, therefore that green color would be less and less visible. For now, set the depth to 0 and transmission color to white. The next parameter I want to talk about is this dispersion ABI number. To see how this works, let's hide the glass and the bottle and unhide the gems geometry and assign our shader. Dispersion ABI controls how much the index of refraction varies across wavelengths. At 0, which is by default, it is turned off, and the lower the value, the more dispersion the shader would have. Normally, you would use a value between 10 to 70 to stay in the normal ranges of the ABI number. Let's set it to 5. You see a very strong dispersion effect. Let's try 10 and see what we get. And this gives us this very strong dispersion effect. And if I set it to something like 70, the dispersion effect would be minimal. And you have 2 presets for diamond and sapphire, which you can use. To get rid of any noise caused by the dispersion effect, you need to increase your transmission samples in the render settings. For now, set the ABI number to 0. Now hide the gems and unhide the shader ball and assign the shader to the shader ball. Next, we have scatter, which allows you to simulate subsurface scattering for refractive objects and can be used to create shaders for high viscous liquids like honey, caramel, chocolate, jam, or surfaces like ice or opalescent glass. Let's set the scatter color to this burgundy color with the RGB values of 69, 15, and 13. For these to work, we need to have a depth distance bigger than 0. Let's set it to 0.05 centimeters. And now we have the base for a really realistic strawberry jam shader. This is an incredibly robust feature. Look at the render. The thinner parts of the shader ball look more refractive, and as the mesh gets thicker, it loses that transmissive quality and becomes more solid, but with subsurface scattering. As you increase the depth distance, this ratio will change, and even thicker parts tend to be transmissive, and only the thickest parts look solid with subsurface scattering. Let's set it to 0.05 for now. And finally, we have the scatter anisotropy, which controls the directional bias or anisotropy of the scattering. The default value of 0 gives isotropic scattering, so that light is scattered evenly in all directions. Positive values bias the scattering effect forwards in the direction that the light is coming from, while negative values bias the scattering backwards towards the direction that the light is coming from. Let's set it to 0 for now. By combining transmission color, depth distance, scatter color, and scatter anisotropy, you can create really advanced shaders. Check this tutorial on our YouTube channel called tutorial number 85, creating the dragon shader in Arnold for Cinema 4D, where I use exactly these parameters to create a really fun shader. Check that out before going to the next lesson to learn more about combining these parameters to create some cool shaders. While you are there, subscribe to Homograph Plus YouTube channel as well. There are some really good content there. Now the lesson is finished, but let's make a fairly better strawberry jam shader while we are at it. I'm gonna set the scatter anisotropy to 0.25. For the specular roughness, load this BW38 blur texture. Hook it up to a ramp float node. Set the ramp float node as the beauty shader. We want to invert the values. Set the Y value for the left point at 0.15 and for the right point to 0.05. Now connect it to the specular roughness input. Let's add some quick bump mapping as well to add some unevenness to the surface. So add a simple noise node. Set it as the beauty shader. Set its scale to 30. Now connect the noise to a bump 2D node. Set the bump height in the bump 2D node 2.25 centimeters. Now connect the bump 2D node to the normal input of the shader. And now we are ready for the final render. Let me just show you the snapshot in the picture viewer that I took for the final render from the IPR. And here it is. So in this lesson, we learned about the transmission section of the standard surface shader. See you in the next video.